So we are going to look at residuals. And I got this sweet calculator emulator here so that I can show you what buttons to push and all that good stuff. Let's get into it. So first thing, you're going to get a data set that looks something like this. And you don't want to enter in this data with these full years, because some of the things that we're going to end up seeing, those numbers will make the numbers too big in your calculator, and your calculator won't be able to handle all the rounding. So one of the things I want you to get really used to doing is stating when x equals 0 what year we are talking about. Okay? So in this case, when x equals 0, I'm going to make it 1970. You get to pick what number you started at. Okay? You could pick 1960. You could pick 1900. Okay? But you need to deal with things accordingly based on that. Okay? So if this is when x is 0. Give me one sec. Movie magic. Okay, so when x is 0, we're saying that is 1970. Okay, so that would mean for us that 1970 we're going to enter in as 0. 1975 would be 5, and then 10, and then so forth. Okay, so be careful with these data sets. They don't have to go in a nice order like this. Every now and then it'll be like counting by 2s and then jump to 5 or something. So just be aware when you do it. So we're going to enter these guys right here into our L1, and then we're going to enter these guys right here into our L2. All right, so I'm going to show you how to do it. If you would like to have the steps, they are here for you. So we're going to hit stat. So I'm going to turn this calculator on, which is kind of cool that I have to do that. And I'm going to hit that stat button, and then number 1 is edit. And I'm going to enter my x values into here. So I've got 0, 5, 10, 15, 20, 25, and 30. Definitely worthwhile taking an extra minute to just see that you've entered these all in correctly. It is really frustrating, and I will tell you from trying to set this video up that when you mistype one number, it's really frustrating. All right, and then we're going to put these numbers in. So we got 81, we got 108, we got 137, we got 159, we got 184, we got 207, and we got 230. So the fact that they line up at the bottom here is definitely really nice. So let's just double check them real quick. 137, 159, 184, 207, and 230. And then the fact that they line up here is really good. If they don't, it means you missed the number, which is a nice visual, but it also just won't work when you try to calculate things. Okay, so we're going to look at this data now. I want to see what it looks like. So to do that, we want to see the scatter plot. So I got the steps for you for that guy right here. So if you need to pause the video and write them down, please do so. Okay, but I'm going to hit second, and then my y equals, which is stat plot in blue there. And I'm going to hit into this first one. I want to turn it on. I want to make sure it's a scatter plot. I want my x list to come from L1 and my y list to come from L2. And then we're going to hit zoom 9. Zoom 9 is going to zoom into this data for us, unless it goes crazy. Zoom 9. And we have this beautiful graph. Okay, so now you're going to use your knowledge of functions and the general shapes and what you know about them to decide which one is going to be the best curve for this. And right off the bat, I mean, this looks pretty linear. So we're going to figure out what our best curve is. So I'm going to get out of here. There's your best curve. So we're going to go back and we're going to hit that stat button again. And then I'm going to arrow over to the left because I'm going to calculate something. So remember, you're hitting stat because you're entering statistics, right? You're going over to calc because you want it to calculate the area of the best curve, or in this case, the best line potentially. So remember that somebody chose what buttons are on this calculator. There is some logic to it. So if you want a line, you want a linear regression, so we're going to go down to 4. We're going to check that guy out. And if you have a calculator that looks like this, you get to pick L1, L2, don't worry about frequency list, and then where you want to store it. If it doesn't look like this and it just tells you linreg, you're still going to do the same thing for this next part, okay? We want to be able to save this into my Y1, so I don't have to retype it over if it's a bunch of decimals. So I want to find the variable, so I'm going to hit that button that says vars, find the variable. I'm going to arrow over to the right, not the left, Miss Holly, just kidding, okay? And then I am going to go into number 1, which is my function. I want to save this in my Y1. You can pick a different one if you have a couple different things going on. So I'm going to enter my Y1, and now I can go down here and I can calculate this. Beautiful. So what's really nice for us here is if I click my Y equals, this is already saved in here. I didn't have to type all these numbers in. I write them down and transfer them over. It's done for you. Okay? So let's go back to our graph and let's check it out and see what it looks like. It looks pretty good. That's not a bad graph at all. Okay? It looks like I got 2 points above it. Looks like I got about 2 points below it. Looks a little randomized, which is nice. If you're comfortable with this graph, then you're just going to move on and you're going to figure out this next piece. I have a little inclination here, partly because I've already looked at this, but since there's a lower, a higher, and a lower, it's very, very slight, but that's kind of like a curvature there, okay? So if we go into stat, and this is just kind of what I want to show you, is you got to play around with it maybe a little bit. You're going to go over to calculate, and if I have a curve, for me, that's quadratic. So I'm going to go to quad reg, down at number 5 there. And I have my L1 and my L2. That's what I want to use. And this time I'm going to hit my vars. I'm going to arrow over. And in my function, I'm going to pick Y2 to see what these guys look like separately. So let's calculate that. Boom, there's my big old equation. It's in here now. And I'm going to graph it. So there's my line. And there's my curve. Kind of hard to see together. Go back to my Y equals, and I can turn this off if I arrow over to the equal sign and push enter, because then that one's not highlighted. So let's go back to our graph now. That gets through every single dot. So that's like really nice. Okay, and the next part I'm going to show you here is how to calculate how close is this. Okay, so we want to look at, based on my curve, what values would be at these different years. Okay, so what's nice about this is you can go to second table and they give you the table. So remember, I'm not using 1970, I'm using 0. So at 0, I want to see what my predicted number is. My predicted number in this case is 81.238. That's crazy close to this number, right? And then I can go down to number 5 to see what it is. And there's my 108.57. Okay, so all I did was I arrowed down through this list, found these values, because this is from the curve, and they are pretty close. They are incredibly, incredibly close. Okay, so what we want to do, they're not exact though, right? So what we want to do with the residual is it tells you how far these values are from your actual data. So what we're going to do is we are going to take this actual data and we are going to subtract the predicted data from that to see how far away they are from 0, because that centers everything down at 0. So if I take 81, and man, I hope you can do this in your head for some of these, minus 81.238, and hit enter, I get negative 0.238. That's really nice. It's very close to 0. It's always easier to compare things than just comparing them to 0. So that's what residual does. Okay? Ooh, that number's not there. That's a lame reveal. Pause. Movie magic. You want to know what's crazy? That was the only one that was missing. All right. So then the next guy, you're going to take 108. You're going to subtract 108.57. No, you do not need a calculator for it. This guy is going to give me negative 0.57. And you're going to do the same thing for each of these. Next guy is going to give me 2.14, negative 1.1. These are the values that you should be getting. And it's just actual minus the predicted. I want to know how far off the predicted is from the actual data. Okay? And so what you can do now, and this is really nice, gives you a nice visual representation, and this is what led me to think, maybe the linear one isn't quite correct. And I'll show you why, but I don't want you to have to go through all the steps with it. So if you go into your stat and you go into edit, you can enter in your residual values here. Okay? If you don't want to calculate all of this, there might be a way to do it in here, but it's just an extra couple steps. If you feel comfortable with a calculator and want to know what they are, ask your math teacher. We'll look at it. If not, and you're just comfortable looking at the table and then subtracting, please just do that. You can always fall back on it, okay? So if you don't want to know how to do this in the calculator, you know what? I'll just show you. If you want to know how to do this in the calculator, I want you to just cover your eyes and ears for like 10 seconds, okay? If you go up to Y3, and I just learned this, so I'm still geeking out about it, you can change what Y3 is. So I want to get to that Y1 value where I have my equation set in there. So if I go over to my vars, right, variable, and I want to go over to Y vars, and that function there, my quadratic was in Y2. So I want to evaluate the equation Y2, and I want it to substitute in the L1 values to see what you get. All right, prepare yourself. All of these numbers. All of these numbers. You see that? How cool is that? Total geeked out about it. So now if you go over to L4 and you arrow up, you can actually do your L2 minus your L3 and hit enter. Check out these values. Do they look familiar? And they're even a little bit more exact. I geeked out so hardcore about this. You can ask Miss Livis and Miss Dickey. They were there to witness it. It was amazing. So what we're going to do now is we're going to do another scatter plot, and we're going to compare your L1 values to your L4 values, okay? So I'm going to go up to my second stat plot, and I want to go down to a different stat, and I'm going to turn this guy on, and instead of L1 and L2, I'm going to make it L1 and L4, okay? And then I'm going to go into my Y equals, because from here I can turn off my first plot, I can turn off my curve. I don't need any of that stuff on. I just want to look at the years versus my residual. All right, so we're going to hit zoom 9, and look at that. That's like really random. There's like a couple above, a couple below. We're not really in a pattern, right? Like if this one was lower, there could be like a curve, but there isn't. Maybe this guy here is an outlier. All right. So that is what a residual looks like. And you really want your residual to be as random as possible. The best residuals are very, very random because it means that you're as close as you can be. The amount that you are off is as random as possible. You also want your numbers, you can't really tell from here in this graph, you want your numbers here to really be between like -1 and 1. That's a really, really good residual, okay? So I got a couple things left to talk to you about. And then at the end of this video, I'm going to show you what the residual looks like for the linear graph, just so you can see. And, you know, if you don't agree with me and you think the linear one is a better fit, absolutely come and have that conversation with me, okay? But just so you know how to finish this here, it has a question down here. According to the data, how many guns will be in circulation in the year 2014? And for us, we're starting at 1970. So we're going to take 2014. Okay, how about 0? How about that 0? Sorry, guys, I'm working on touchscreen computer. 2014, and I'm going to take away my starting year of 1970. So I'm looking for 44 on my table. And you don't have to scroll all the way down to 44 because that is super, super annoying. You can go to second window, and you can tell your table, hey, start at 44. And now when you go into your table, it's just going to jump right to 44 for you. If you have your graph on, oh, Miss Holly. You know what's nice is that you guys might do the same error, and now you're going to know, right? So according to this guy, in the year 2014, there is going to be about 286 guns circulating, okay? I would round this up for multiple reasons. 0.8 of a gun counts as a full gun, in my opinion. You could probably argue it the other way. I would chat with your teacher and see what their expectations are as far as normal rounding, or, you know, if you're talking about population, you know, is 0.2 of a person a whole person? Yeah, I think so. So it just depends on the situation, the real world application there. If you have all this junk in your calculator and you need to clear it out, if you just want to clear the stuff from your stat, you are going to go into stat, you're going to go into edit, and you're going to go up to the top where it's L1 or L2 or L3, and then you can hit clear and the down arrow, and that gets rid of everything for you. If you just don't want to deal with anything and you want to reset your whole calculator, and I am warning you right now, do not do this. If you have programs saved, they will go away. But if you're using like a school calculator and you just want to wipe everything so you can start fresh, that's what I did with mine when I was doing this. You can reset your calculator, which is second +712. That is all you have to do. All right, so if you're good with this and you're feeling fine, by all means, stop now. And then if you would like to see what the linear one looks like, I'm going to pause the video and reset everything. To do that, I'm not going to walk through the whole step. I just want to show you what it looks like. All right, movie magic, and it's all done. So the graph you see right here is the residual graph for the linear prediction. So when we looked at the linear prediction, it looked pretty good. It was about even above, even below, which is really nice. But the one thing that really kind of threw me is that this kind of looked like a curve, like it was a very lower, lower, upper, 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 lower, lower. Like that's that nice curve. And when you see a pattern with your residuals, that's usually throwing you off to tell you there's a better model of fit for this. So I just wanted you to be able to see that. If you'd like to see them together, I'm not sure if this is going to work well or not, but we'll find out. 9. Okay, so the open dots here are the first one that we had was the quadratic, and then these little plus signs are the linear one. So can I turn my? See, now I'm playing around with it too much. I know there's a way to turn off your grids because I'm kind of in the way here, but it's okay. So if you look at the open circle ones, the ones that we ended up using, I feel like just seem a little bit more randomized than the little tick marks. And maybe there's a prediction that's even better than this. But the ones that you're going to see are going to be fairly obvious. We're not going to try and make you solve tons and tons of, spend lots of time on one of these problems. But they're a little labor intensive. So you have this video to go back and reference. I'm sorry that I rambled a little bit. Hopefully it was helpful. And let us know what else you need.